And by the way, it's always uncomfortable talking about this, but I know there's a few of us that could possibly fail this course. There is a 103 in the spring that has plenty of room. It's at night, though. But at least that's the worst thing about a course like this is if you fail it normally, everything's full. And you're like, well, I'm doubly screwed. So there is a 103 in the evening that's got plenty of room. And they actually want people so that it won't be cut. Everything's coming. They're like, if you have that 80% of your cap, and we won't cut you. And oh, shit. So that's there for you in case.
Is it a good professor?
Say again?
Is it a good professor?
I can't remember who's teaching. But at this point, it's like almost your only option. So there are wait lists too. What's that?
I was going to help on purpose.
I'm sorry. I didn't mean. I just wanted to let you know in case there is somewhere to go, because that would be really sucky. Is if you fail and then there's nowhere else for you to go. That sucks. All right. So what was it?
Oh, completing this way.
Okay. I take your hope and I crush it. That's my job. All right, so let's do one that's got a coefficient to it. All right, so something like this. So completing the square, right? So there's a couple things you could do first. There's a couple cleanup things you got to do. What are those couple things? The process of completing the square comes up with a number that I put somewhere. What's in my way?
3 times 11.
I'm not factoring. In fact, it won't factor.
In front of the x.
Sure. You can divide by 3. That's one thing you got to do. Because completing a square only works when that first number is a 1. And I love when people divide 0 by 3 and get something other than 0. Don't do that to yourself. It's 0. And then what's the other thing I got to do something with? Yeah, I got to get that out of the way. Because the process of completing square wants to put something there. I got to make room for it. Got to get that out of the way. So you get x squared minus 6x with some room equals negative 11/3. So now I can apply. Now everything's been cleaned up. Those two things are taken care of. Get anything out of the way that's in the way. Divide by anything that's in front of your x squared. That's just setting it up. Now I can do completing the square. And what is involved in that? How do I complete this square? What 2 steps do I need here?
Take half of 6.
Good. Take half of negative 6. And then do what with that? Square. So what's the 9 for? Yeah, that's what I need to put here. Because how would you factor this? What times itself? What makes 9 and makes negative 6? Yeah. So that's why this guy is always going to tell you how to factor this. It's kind of built that way. So this factors is this. And then that, what do you have to do on that side? Common denominator. So this gives a 3. So 27 minus 11. Let me stop there for a second. You guys with me? So the actual completing the square step was only this. This was all getting ready to do this. And this is just cleanup after doing this. Right? So that's really the only part that's completing the square is figuring that number out and that number out. What do you have to put here so that it will factor like this? But now, what's the whole point of this? I hate it when people get here and then they start to FOIL this thing out again. We did all this work to make this look like this. Why? I ask my question, man. Do this stuff. Why am I doing this? Yes?
Where did, on the part there, it says 9 times, I'm hoping to see if it's out there, it says 9 times 3. Where did you get that?
Yeah, well, it's 9, right?
Right.
It's 9.
Right.
And then how do I add 9 to negative 11/3?
Okay, got it.
Yeah, that's just that stuff. Yeah, it's just me getting that so I can put those together. So the plus 9 and the x minus 3 squared, that's completing the square. Anything else is just, oh, there's fractions. I got to put them together. It's just cleanup stuff. But now what can I do? What's nice about this form? What can I do? And too many people are doing stuff like this. Good, that's the right reaction to make. You can't break into a square and take something out. No, this whole thing is stuck in there, which tells you what you want to do. How do you kill this dude so that they're not stuck anymore? Square root. We know this. We know if I have something squared equals something, I just take a square root. And the minute I do a square root, I plus or minus. So this side becomes x minus 3. What's the square root of 16? 4. What's the square root of 3? I don't know. And then one last step and you're done. Yeah, add the 3 of them. And you're sort of done. I mean, if you stop here, I'll be cool with it. But what should you do with this? Do you guys see something you can do there? Some of you guys noticed this and didn't know. I don't care. You can stop there. That's fine with me. But you see how you can rationalize the bottom? It's sort of like saying 6 over 8 is the answer. Well, you should reduce it. It's the same sort of thing as you stop here, and most math teachers will cringe a little bit. You want to go one more step. Multiply by rad 3. But if you don't see that, I'm fine with stopping without rationalizing. It's fine. It's technically the right answer. All right, you guys cool with the important parts of this problem? How do you get things set up correctly so you can do this? You know how to do this, and you know why we do it. I mean, why do we do it like this? So that I can do this directly. I can just kill the square directly. Cool. So don't forget now. I'm going to make sure, obviously from the practice fine, I can tell us, but just to make sure everybody knows, tomorrow's final is cumulative, right? It's everything.
Yeah. What about,
Which one?
Is 3B similar to that?
3B?
B? Yeah.
Maybe. What do you do first with 3B? If I just say solve and I don't tell you how to do it, good. You try to, you think factor, but what do you have to do first, of course?
Make it equal to 0.
Make it equal to 0. I like it, because when you factor and it's not equal to 0, you factor too early. So you take 2x minus 8. So if this was not factorable, then I could do completing a square or quadratic formula if I wanted to, right? But that is factorable all day long. Is that cool? So if I can factor it, that should be the quick way to do it. I know a lot of students sometimes, they're like, oh, thank God, quadratic equation, screw factoring forever. Oh, shit. You better know I'm going to ask you to factor. In certain problems, you can't just pick your own method. But in this one, you can pick your method. So you could do quadratic formula here, but that's just crazy, because how do you factor this?
X minus 7 plus 4.
And they get you 2 answers, right? Bam, bam, bam. So much better and quicker than quadratic formula. Yeah.
Is on 3h, that's not factorable after you take out the x immediately.
Exactly. So how do you do it?
So then I would go with
Then you do
completing the square.
or quadratic formula.
Okay. Which is easier, do you think?
In that case, quadratic formula, because the 3 is in the middle, you're going to introduce fractions, which would be a little grosser looking, right? I don't know if you can see what I'm saying, because you got to cut the middle in half. So you might as well just throw in quadratic formula, because you can see all A, B, C.
Okay.
So 3h, you guys see that? 3h.
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 Yeah, you just put in 2 0. 1 0.
Is that right?
Yeah.
So of course it's equal to 0, so what do you try to do to this side?
LCD first or grouping? LCD first.
GCF.
GCF.
All right.
Yeah, take X out.
Take an X out. Yeah.
Yeah.
And a lot of people miss that.
LCD. Okay, no problem. Yeah.
And so the real quick, so now I can say, can you factor this? No. So you say x equals 0, that's an answer, done. Or x squared plus 3x minus 7 equals 0. You better not circle that damn thing. That doesn't tell me what x is, so you're not done. But how do you solve that equation? Quadratic formula. Or completing a square if you want to, right? Because quadratic formula is completing the square. It's just a different way to say it. So how does quadratic formula work? What's the formula?
B squared.
Plus or minus b squared.
I like it. Now, you mad people want to make us acknowledge. I don't know. To be honest. Oh, well, this is one you should know. I mean, just gotta know it. It's humans did this. You should know. This didn't come from us, from aliens. What's A, B, and C?
A is 1, B is 3.
4 AC, yes, sir. Is that cool? A is 1. Good. B is 3. C is -7. So the signs do matter. And then it's just plug and chug, right? It's just plug and chug. If it doesn't factor, you can use quadratic formula or complete a square. If I don't say, it's just says solve. So you can use either way you want to. If you have a graphic calculator and you know how to make it give you answers to this, well, that's not good for you, actually, because I better see some freaking work. Right? Show me right answers out of nowhere, you're going to lose all the points, because I don't know where they came from.
Will there be any relation to this to the negative b over 2a?
Totally. This is why I did chapter 11 out of order. Out of what the book does it out of order. Let me say this correctly. The book does it out of order. Because in 11.1 they tell you this is the shortcut to finding the vertex. But remember, when I set this equal to 0, what am I actually finding graphically? When I set a function equal to 0, I'm finding the what's?
Why?
The x-intercepts.
Yeah.
Because I'm making y 0. I'm going to find the x-intercepts, right? So these are the x-intercepts. Those are the x-intercepts. That is the x-intercepts for any quadratic. That's the x-intercepts. That's what that is, because it solves this kind of equation. That equals 0. So if, remember, the very first time we did a parabola, it was like 2 and 4 were the intercepts. So where must the vertex be? Bless you. If it's at 2 and 4, where must the vertex be? If those are the x-intercepts, the vertex must be at 3.
Yeah.
This is negative b over 2a, give or take that. So negative b over 2a is right in the middle. That's why that's exactly the same thing as saying 3 must be the x piece of the vertex. It's the same thing as saying negative b over 2a must be the x piece of the vertex. Because it's the thing that's right in the middle. Anyway, I'm sorry. I just redid my whole lecture there in under a minute. But yes, short answer, yeah. Right? It totally has everything to do with this, and that's why I hate that this book does this before they do that. That's insane. That doesn't make any damn sense without knowing this, to be honest. Yeah, sorry.
I have a different question for different problem.
Sure.
I have a question on this.
Okay.
The negative b that's before the plus and minus. When you plug it in, what are you supposed to do with that over there? Like,
Well, what is b?
it's -3.
No, what is b? What is b?
Oh, 3, sorry.
So then,
yeah.
negative b plus or minus square root of, and what's b again?
3.
3 squared minus 4 times. I just plug it and check it.
Yeah. But what do you do with that -3? Because I know how to get all that right here, but what do you do with that
What do
-3?
you keep writing it? I'm sorry, I don't know what to tell you.
But when you get your answer, I'm saying like at the end, like I know how to get all that over there.
All right, let's finish this out.
Okay.
What do you get here? 9
Plus 28.
plus 28, so 37, right? In this case, I stop. I'm done.
Oh,
Yeah, I don't know.
okay.
Can I do anything? Can I reduce this radical?
No.
No way. 37 prime. Is there anything I would reduce amongst everybody? No, so I'm done. But if it would have come out to be like -6 plus or minus 2 rad 7 over 2, then I could divide both of these by 2, and it would be -3 plus or minus rad 7.
Okay.
Because what's being divided by 2? This and that,
Okay.
right? I think that's what you were
Yeah,
trying
that's
to
what I
say.
meant, yeah.
Otherwise, until you get to the point where you start to reduce or something, you just keep writing them. You just
Okay.
keep write them again, write them again. Yeah.
So for something like 1i, when you don't have like terms, would you have to reduce them down?
nothing you can do except for the rad 3, because that just becomes 3, right? But the other ones, there's no way to make them because they only have 1 of anything in them, right?
So then
You're done after like 2 steps.
Oh, okay.
Let's see. I cannot do anything here, but I can do something here. Right? If you get what I mean, you're in a good place. I can't do shit there, but I can do something here. I can't do anything here at all because that's only got 1, 2, 1, 7. That's only got 1, 7, 1, 5. There's nothing I can do. And some of you guys, I don't blame you because one big thing about math is you're like, when do I stop? I feel I didn't do much. I have to do more. So there's one problem. I think it's the one you're talking about. Number 1J, where people try to force it to do more. Right? But if I get to this point, I stop. It's not like terms. I can't do anything with the radicals. There's not 2 of anything. So why can't I do something with this radical? Yeah, it's 4 times 7. There's 2 2's in it. There's 2 of something in it. So then I can do something with it. Here I can't do shit. But here, this is 2 rad 4 rad 7, right? Rad 4 is times 2 is, so I got 4 rad 7s plus 5 rad 7s is 9 rad 7s. So I can do something. So that's what you look for. Can I reduce a radical? No, because there's not 2 of anything. Are they like terms? No. So I stop. You're done. You just stop. Here you got to keep going.
That correct answer to the one you circled on top, then.
This is right. These are 2 separate problems. This is problem A and problem B.
Okay.
2 different ones, right? So that one you can't do anything with. This one you can do something with. Jason?
Yeah, 3E. I know it's simple, but I guess maybe I'm just not, I forget where to start.
So when I have a system of equations, and this one is, I forgot to, oh, it doesn't matter. 3E. So what methods are available to you to use here?
You can solve for y.
Good. I could take the second equation, solve for y. So add the 2x over, is that cool? And then what can I do with this?
Plug it in.
I can replace y with it, right? That's substitution method. Or you could multiply this by
Do elimination.
5, multiply this whole thing by 5, and then do elimination. So it's like the
It's easier
3-term
with
deal,
two.
but now it's just 2, so it's much easier.
Yeah.
There's less, because if I have 3 unknowns and 3 equations, the first thing I do is try to create one of these. Why do I do that? Because one of these is a lot easier than the 3 by 3. So if I make a little 2 by 2, you know what I mean? I would say 3 by 3, 2 by 2. There's 2 equations, 2 unknowns. Even though technically there's 1, 2, 3 pieces to it. That's what I mean when I say 2 by 2, 3 by 3.
Are we going to get an answer key for this as well?
Yes, I have it. I was about to give it to you. Yes.
I didn't understand. I didn't even know that we had to do this until just now. It was complex. Hold on.
Conjugates?
Yeah.
Here, let me. I'm going to go ahead and pass these out. Here's the answer key for that.
Complex solutions and standard.
So where's it at? Sorry.
It's not in this. It's 11.4, number 63.
Oh, what's all right.
I don't have any notes on this either.
No. Yes, you do. I just didn't say those exact words, but what is any complex number? What's the form, the standard form if you want to get there, but what's the form of a complex number? A plus bi. That's what you call standard form of a complex number. Is a plus bi. So you're just saying make sure your answers look like a number plus a number times
But
out.
this one doesn't have a b.
Beautiful. One of these could be 0 all day long. So if my answer is 7, 7's fine. You don't have to do this, but I understand that that's what really is going on. It's still 7 plus 0i, so it's 7. So that is in the right standard form of a complex number. It's just there's no imaginary part. You got 0 for b, no big deal.
So then, number 63, the answer would be 16i. I don't feel like that's right.
No.
But you said a plus b, I.
Yes, but I don't know what work did you do.
I did 16 plus 0i because 9.
I don't.
isn't-
No. The instructions about writing it in complex form, standard form, is what to do with your answer. What work do you do to this to solve it? You have to solve this equation. The complex standard form crap it only comes in at the end. They're telling you how to put your answer, what form. But how do you solve this equation? What do? How do you solve this equation?
Divide by.
All right, watch. How do you solve this equation? Square rooted. Okay. Why was that equation easier than this one? And what can you do to this one to make it that easy?
Take away the 9.
All right, now we're talking. Get the x squared by itself, right? So you say to yourself, if only that one there, and then I can do stuff. All right, well, make that happen. Take the 9 away. And what else can I do?
Square. No, 16, yeah.
Now it looks just like that. Is it pretty? I don't care. Yeah, it is actually, because 9 and 16 are both squares. And it's negative, but we don't care anymore. We're cool with that. If I see a negative, I'm going to take a square root. I'm going to end up with then I. Plus or minus. Square root of 9 is 3. Square root of 16 is 4. And square root of negative 1 is I. So let it be that simple. If you know the square root of 49 is 7, then you know the square root of negative 49 is 7i. Bam. So the I covers our ass for it not being real. It says, all right, then it's imaginary. There you go. Again, an unfortunate word, but all.
Can you do like some of the older problems? Because like
Yeah.
the newer stuff is.
It's up to you guys.
For like one.
For like 1F, it's probably really easy, but
Oh, so the thing with 1F, one thing that really sucks for people is if they see that and they start to multiply, because oh my god. But what's it saying to do? Subtract.
yeah.
So
Just combine like terms.
the key thing with that is to bring the negative through.
Okay.
Right? Distribute the negative and then just put your like terms together. That's it. That's all that problem is. You can call it subtracting two polynomials to make it all sound official, or you just say put the like term together, and then that's what you do.
Okay.
Should put a few of those in, like 4 or 5 of them.
Yeah?
Yeah.
Make the whole thing a bunch of those?
Yeah.
Alright, I'll take that into consideration. No, I've already decided. Oh yeah. Go ahead.
For 1C, I got 8x3 minus 27 as well, but then I saw that I could cube that, but in the answer key you didn't do that. So
Wait. You saw you could do what? So you get here. Are those like terms? No. So what else could you possibly do?
this is what I did. I got.
Yes. Now look at the original problem. Look at the question. Look at the original problem. I really want you to see this. What was the original problem?
What number is this?
1C.
1C, yeah. Now look at your answer. Now look at the original problem. The problem. So you went right back to where I started, right? Do you see that? Isn't your answer the same as what it started off as? So that means you went too far. I really want this to make sense. And for some reason, even in my own math community, they don't understand this. And I'm like, come on, guys, pull it together. Simplification means do the operations. Factoring means undo the operation of multiplication, right? So they are complete opposites of each other. If I say simplify in your factoring, that's bad. Never. That's the opposite of what I'm asking you to do. Does that make sense? So we start to feel like when we factor, we're simplifying it because it just makes it easier to work with, but your simplify means do the operation. So if I give you a problem like this, and I say simplify, that's you multiply, because what's the operation? So once you do that multiplication, you're done. You've simplified it. There's no more like terms. If you factor it, now you're undoing what I asked you to do. In fact, you got right back to where you started. How do you factor this? Isn't this 2x, 2x, 2x? 3, 3, 3. So you're just kind of proving that that goes back to this. I didn't want you to do that. Just simplify, done.
So what
Is that
happened to, so in the, are you foiling that? Or?
Totally.
Oh, okay.
Have you done it?
No.
I mean, this is the reason I gave you this problem is, again, I gave you a problem like this before, so you can actually see this killing the shit you don't want. That's the cleanup dude. So here I get 18x, right?
Mm-hmm.
And here I get
18x.
negative 18x.
Oh, yeah.
So that's why you're worried about why aren't there more terms?
Yeah,
because they kill each other, because
yeah.
this is exactly this times this, like it's supposed to be for that to happen. If I put a 5x there, you're going to have a lot more terms, because they're not going to kill each other like they're supposed to, or, like they could. Yes?
So 1e on the very bottom.
What, sorry?
9e.
9e?
1e.
1e. Sure.
5x cubed. Can that be factored? I don't remember how.
Well, not really.
No,
It's
right?
factored, but you could write 5xxx. But all that matters is if you see a 5, you can kill it. If you see some x's on the top, you can cancel some x's.
Okay, so I didn't.
Yeah, so there was an extra x on the top.
Yeah.
That's why I end up with 2 x's on the bottom at the end, because one of them canceled with the x that was on top.
Okay.
Yes?
1D. Why don't the y's cancel?
The only way two things can cancel is if they are the same. Are y to the 7th and y to the negative 7th, are they the same? No. Y to the 7th and y to the 7th is the same. So if I add a to the negative 8 over a to the negative 8, don't pull your hair out, that is 1. Of course. Right? It's a negative power. No, it's something divided by itself. It's 1. Bam. But if I have a to the negative 8 divided by 8, for example, a to the 8th, for example, that's not 1. They're not going to cancel each other. What happens? Who moves? These 8a's move. Do these go anywhere? No, they're positive. They're fine where they are. So these come down. So what's on the top now? 1. You understood 1. How many a's are on the bottom now? 16. Positive, because when it comes down, it becomes positive, right? Is that?
And since it's not the negative 7's on the bottom, it goes up.
In this case, it would go the other way. Exactly. So that's why you end up with 14 y's on the top, because those 7 y's on the bottom come up. You see that? Negative power means flip. So those negative 7, the y's, those 7 come up. There's already 7 up there, so now you have 14.
Okay.
So I don't really apply the properties because it's easier just to do that. 7 minus negative 7 is 14, but oh my God, in your head, minus negative can very easily get confused. Bring them up. There's no negatives then. I know. It's almost over, guys.
I don't know if we already went over it. 1E.
1b?
E, I think.
Sort of, not really.
Factor,
well,
right? And then
I did it with a tutor.
Yeah?
Mark. And I wanted
Don't call him out, poor guy. Well, it could only be.
So this is my answer, which you have too, but then I was like, can we cancel these? And he said no, but then I see that you did cancel it.
Yeah, because the...
One's all negative and the other one's.
No.
That's why.
So I'm just going to focus on the part you're talking about. So there's that on the bottom, right? And here's this on the top. Right?
Well, I haven't.
Well, I know, there's an extra x, but take it out, right? Is that cool? So there's an x here, right? Take an x out.
Okay.
All right, how are we doing so far? Is that cool? Yeah. Let me just write everything.
Why don't we just write it like that?
You're doing E, right?
1e, yes. All right, so that's everything, right? Everything's there. What's the matter? Look at the beginning.
Oh.
Right there at the beginning.
Okay.
Right, just take an x out, and that's all I really did. Right? How do you factor this? X, 3, 3, 3. This is a minus, so this little dude is going to be x minus. And you know, I was thinking about something. Let me show you something. Let me see if you guys like this. What if I did this like this? And just watch this. Just watch this. That's true, right? So this will be x, and this will be negative 3 times negative 3 times negative 3. You with me? So then in the little dude, I put 1x and 1 negative 3. See, so you don't have to remember that this little dude's the same sign. Even though I think that's not a big deal. But this is what you can do with negative, is they're actually all negative then when you break them up. And the big dude goes 2 x's, 2 negative 3's. What's negative 3 times negative 3? Plus 9. So see, then you don't need soap. Right? You can stop using soap. Right? Or shortcut soap. Please continue using some kind of soap. Why is it positive? It'll always be positive, because if they're both negative, it's positive, they're both positive. Right? That's why it's AP, always positive. And the middle term is opposite sign. Yeah. That one I can't. You just got to remember that's a cancellation, dude. Isn't that the same as that? So this big dude cancels with that big dude. Of course they do. So the mistake that you guys made was that should be a plus right there, because that's a minus. The little dude is the same sign, and the big dude is the opposite of that. It's got to be so that things cancel correctly. Yeah?
When you have a function and you're asking for the domain, how would you set the function equal to 0?
It depends. I really want you guys to understand that a square root, there's no reason it should act the same as a fraction. There's no reason they should act the same, right? So we don't know many functions, because if you went to like trigonometry, so you get all these other functions, and then you kind of talk about it in a bigger way. But I don't care what function you learn. So if I had this, I say, okay, let me just say this again. I say in English what I don't want to have happen, or what must happen, and then I write that in math. So what can I not let happen? Don't go to the answer. Just say in English what can't happen in a fraction. The bottom can't be 0. Right? So in English, the bottom can't be 0. So in math, the bottom is x minus 7. Can't be is not equal to. 0 is 0. Then I solve it. So what can I not have happen here? What can I not allow to have happen? And when I say domain, if I meant include complex numbers, I actually have to say complex domain. I actually have to be. So when I say domain, it means real numbers immediately. So in order to have a true real domain here, what can I not let happen? Yeah, so how do I say that? I must have the inside be what then? Greater than or equal to. It just can't be negative, so it could be 0 or bigger. Right? I didn't write the English down, but I said in English, the inside must be at least 0 for this to be real. So then write it. The inside is this, at least is this, and 0 is 0.
What do you do with the square root?
No. So I didn't do something to this to get here. I applied an idea. And that's when things get really rough. But, I mean, if I just said, give me some numbers that you can put in there and have it come out to be real, nobody would give me a negative number. So all this is saying is, what can I let 2x minus 7 be? Anything that's at least 0, I can let it be that. So what can I let x be? Solve for x, and you'll see. So could I let x be 0? Just looking at it, could you let x be 0? What would you get? You get a not real, so you know you couldn't. So x has got to be somehow bigger than 0 at least. Can I let x be 1? What do you get if x is 1? You still get a negative. Oh shit, so it's bigger than 1. But I don't want to do that. That might take forever. 2, 2.7, 2.7839. Screw that. Let's do the algebra. Add 7 divided by 2. Now I know that's just got to be at least 3.5. At least 7.5. Is that?
So that's the answer right there.
Totally. Yeah. This is what has to happen to what's inside, and this is the x's that make that happen.
Well, it's actually on the test. I'm wondering what I did wrong. It's g of x equals 2b.
Oh, so I like this. Beautiful, beautiful. So would anything be different here, domain-wise? Would anything be different here?
Yeah, because can a cube root handle a negative?
So what would the domain be here? Yes, because it's an odd root. It can handle negative. What's the cube root of -8? -2. Who cares?
Can you do one that's not like all real numbers? Like if you had
Like
a
this
four,
one?
Like, yeah, like let's say you had a 4 there.
Does that make sense, Chase?
Makes perfect sense.
All right.
I get how you can get all real numbers because if it's an odd number, it's all real numbers.
Sure.
But if it's an even number,
Like this one. It's a square root, so that's why we had to do this. So if I had a 678th root, who gives a shit? It's even. That's all I care about, right? Do you see what I'm saying? I wouldn't do this because then somebody's going to freak out, and I understand that. You're like, okay, but I don't care how big it is. 600, whatever number that is. It's even.
Yeah.
So what can I not let happen with this? What must happen with that? What must be true about that? Since this is an even root, 7 minus 5x has to be greater than or equal to 0. Bam. Right? Do I care that it's this disgusting root? No, because all I care about is what am I allowed to put in there. So I can let this number has to be at least 0, and then I can solve to see what x's make
so
that
the
happen.
same thing you did over here.
Exactly the
Okay.
same. Because it's an even root.
Mm-hmm.
If I did this, whoop, right? Now it's an odd root. I don't have to do this. They're all real numbers. That's the answer, because it's an odd root. I'm not going to do that to you, because that would be a little evil. But I really want you to see how, who cares? All I care about is it odd or even. It's going to tell me how, if they're uptight or laid back. All right?
Mm-hmm.
Yes?
So 5B, I know it's simple, but I forgot how to do it.
5b?
Yeah.
What's parallel lines mean? What's got to be true about two lines that are parallel? The slope must be the same. If the slopes are a little different, then one's going to run into the other one, right? And what two things do you need in order to figure out the equation of a line? You got this guy here, right? And what's the other guy?
Y1, Y2. And then
Huh?
X.
No?
E,
M.
M.
Real quick, look, I really want you guys to get this. I didn't teach this semester. You're supposed to come in knowing, so we reviewed it. But what is this? You guys normally know this. Some of us still put the x's on top for some damn reason, but what should it be? It's m equals.
Y2 minus Y1.
over X.
Oh, yeah. Mm-hmm.
So all this equation is. Do you see how if I multiply these up, then the base would become that? These are the same damn equation. It's just that these little subscripts mean I have to use a specific point, this point and that point. But for a straight line, does it matter what points I pick? Will the slope change because I pick two different points? Of course not. It's the same. So that's what this equation is saying is pick a point and then pick any other point. Don't make it specific. Any damn point you want to. Multiply that up. There's an equation of a line. Because in order to get a line, what do I need? I need a point and a direction, and then I got a line. So that's what this. I need a point and a direction, and then I got my line. So I love how math shows the same thing you would say, what do you need? This. Well, that's what the equation means, because that's what you need. So that one, if it's parallel to this line, what's my slope? 5, because that slope is 5, my slope must be 5. And it goes through the point -4, 2. I got everything I need now to do this, right? Y minus what? 2, that's the y piece, equals m. X minus, that's where people freak out here. X minus what?
-4.
-4, not force, it's -4. And that should be simple to simplify.
Could you have used the top?
Yeah, there's a way you can use this.
Okay. Yeah.
Sure.
I know how to do it, yeah.
Good. All right. I like it.
I was just asking if I could use that one.
want to point out something too. It's as if you don't already have enough. But if my practice final is just not doing it for you, on page 791 in the book, there is a chapter 1 through 11 cumulative review. Page 791. So if you're tired of, yeah, Jeff, you got your own way of doing shit. Now, the thing you got to be careful about with this is there might be things we skipped over that's in there. But still, all the answers should be in the back, I'm pretty sure. So it's another place to go review.
So for 7, so find the x-intercept.
Yes?
You can use the -3 plus or minus.
You have to, yeah. Or, yeah, you could. You could do continuous square or that because it won't factor.
Okay, or I can do the x, y, z.
No.
No?
Because if you try to find, I don't know, if you try to find the intercepts this way, and the actual answers were 5 plus or minus the square root of 31 over 11, I really doubt you're going to get that from here, right? You're not going to get, let me try my favorite number, which is this. Well, what is it? It's never going to happen. So, yeah, you want an algebraic way to do it.
When I graphed it, if it was the 5 plus or minus, it's just the 5 and the 11?
No. So, this would be the vertex part, right? That would be the vertex part. So that, do you have to graph this? No, I wouldn't use this to graph it. But if I'm asking you to find them, you should. So, I really want you guys to understand. You could plug this in your calculator and see what they were as a decimal approximation and then see that they meet. So, for example, that problem, I think I did number 7. Just humor me for a second. And again, you guys are like, that's all we've been doing, man. Here's the graph of the answer here, just really rough. Right? Basically, that's it, right? I mean, please, dear God, if you do that, no. That's a privilege, Jeff. No, all right. So what I get for my x-intercepts, I got 6 plus or minus 2 rad 11 over -4, right? Which you can do stuff with, but I'm like, whatever. That's good. If you got it there, I'm happy. Right? So somebody help me out. What's 6 plus 2 rad 11 divided by -4? I'm going to pick that one answer. Can somebody do that in the calculator for me? What is that? It's going to be a little bit more than that.
It would look like
-3.2 or something like that. Sorry, it's number 7. I just really want to show you what's going on the picture there. Do 6 plus 2 rad 11, enter, and then divide it by -4. I mean, you got to be careful how you put this in the calculator.
-3.15.
All right, cool. Hey, all right. So that's this here, right? And on my graph, look at my graph. And I didn't make my graph beautiful. I didn't even do it. Did you see where it hits the x-axis? Isn't that just a little bit below -3? If you look at the answer key? Do you guys see that? Here's 1, 2, 3. So it's -3.1, blah, blah, blah. Kind of with me? So these are the x-intercepts. Do the x-intercepts have to be pretty? No. There's all kinds of ugly numbers living on this thing. So what about the other one? 6 minus 2 rad 11 divided by -4.
barely a positive.
Barely a positive, which is going to go along with this one, right? I don't know if you guys see that. I mean, if you do that in the calculator, you'll get like 0.2 something, maybe something like that. And that's going to relate to that x-intercept right there. Did I use these to graph this? No. I just want you to be able to find them. I'm just making you do quadratic formula in a different setting. Do you see what I'm saying? I can ask you a question, use quadratic formula to do it. That's great. Now I want to give you a totally different setting, but you still just got to use quadratic formula just to make sure you know when to use it. So I'm not saying graph this, my God, no. I'm saying find them, and then you can see. Now what's the easy way to graph though? If you find the y-intercept, then you have the same thing on the other side, right? That's the quick way to find nice points. Get the y-intercept, which is always easy to find, and then you have another point equidistant on the other side. I like the word equidistant. You guys heard about the planet they discovered in our solar system?
Yeah.
And they haven't actually seen it. They've only...
It's about the size of Uranus, they're saying. Uranus.
Yes, you gotta be careful when you say that. All these immature people, including me. What's up?
How are they supposed to find a planet in our solar system when they just demoted Pluto? Like, I just thought...
I know, it's horrible. I was going to say it should be Pluto Senior out of something. Somebody was asking what's the name of it. They haven't named it yet, because they haven't actually set eyes on it yet. They just used theoretical models for what they've seen stuff doing out there. They're all clustering somewhere, and the only way that would happen is if there's a gravity of a large enough thing to be a planet. So now the next thing they're going to do is they focused on this X section of sky. They're going to observe it with this telescope. The only telescope strong enough to see that far. They have to scan this region of space, and they think it's going to take about 10 years to actually set eyes on it. It takes about 20,000 years for this thing, if it exists, to go around the sun.
How many years? 20,000?
20,000, yes. 10 to 20,000, something like that. Yeah.
We've seen the shirt that says, it's like, has a picture of Pluto, and it says...
Rest in peace.
And it says, your mom thought I was big enough.
Oh, no. Oh, no.
Because of the generation.
That one I have not seen. I could have guessed that it exists. I have one that says rest in peace. Poor little Pluto.
Just could you please explain 9E, which is I...
Oh yeah, that's right. I don't think I ever... Did I answer that question?
You showed us like on the test question as well.
Oh yeah, that was somebody's question I never got back to. Alright. Well, what's I to the 23? How do you do that?
We have to say 4 times.
4 goes into 23. Who cares with how many left over?
Negative I. 3.
With 3. So this would be I cubed, which is negative I. I like it. So I to the negative 23rd would be that flipped, because the negative power just says flip. Are you with me? So whatever I to the 23 is, I to the negative 23 will be the reciprocal of that, of course. 3 squared is 9, so what's 3 to the negative 2? 1/9. That's all a negative power does. Right? So this would be 1 over negative I. Why is that not good to stop there? How do you...
It's a radical.
Yeah, it's a radical. Good. Multiply by I. The complex conjugate, if you want to think about it that way. Right? I don't know if you guys are with me.
Yeah.
So 1 times I, I'll do that as I. What's negative I times I is negative I squared.
Negative 1 at the bottom.
Negative negative 1, which is 1, so I just get I.
I lost you at the beginning, so
At least you know where it
I gotta get
happened.
to the rest of the part too. But so wait, 5 goes into I.
4 goes into
4,
23
5
5 times with 3 left over.
So where's that 5 go?
It doesn't go anywhere. So it's like I'm saying, I know this is weird, but here's 1, here's I, and here's negative 1, here's negative I. When I multiply by I, it's at quarter rotation. That's why 1 times I is I. I times I is negative 1, because I turn again. So every time I turn 4 times, I'm at 1 again. And then I do it again. So how many times am I going to make a full rotation? 5 times.
Okay.
So all that matters is 1, 2, 3, 5. And then how far past that am I going to go? 1, 2, 3. That's why the answer is negative I. That's where I end up.
Okay.
So this picture is really a cool way to do that kind of problem. That's the visual of what's behind this shortcut. I'm just taking out all the rotations just to see where it really ends up. If I spun 7 times, 7.5 times, I can accomplish the same thing by doing this. All right, now I'm facing the way I would have faced, and I feel better. I'm not going to throw up. Okay?
Okay.
That's cool.
You got 2 different answers. You got that and that.
I didn't get 2 different answers. Where are my 2? I got my 1 answer right there. That's the only answer I got. If I ask you what 4 to the negative 3 is, you could figure out what 4 cubed is. What's 4 cubed? 64. So then 4 to the negative 3 is 1 over 64. I only got 1 answer, but I used this to help me get to my answer, right? So just to take the negative out of it for a second, we know how to do this. Whatever answer you get here, you flip it. That's all. That's all a negative power means. Just flip the answer you normally get. Let me show you one more thing. This is a little bit freaky. And this is actually, so many cool things about math you'll never see. I feel bad for you guys, but There's so many ways to write 1, you have no idea. And the weird thing is, it's really useful to know how these different ways. So what's another way to write 1? Isn't this another way to write 1? Isn't that another way to write 1? Think about it.
Yeah.
Are you agree with me? So then, if I multiply anything in the universe by this, it will stay the same. Because when I multiply by 1, it stays the same. Are you with me? This is weird, what I'm about to do. It's weird. So if I ask you what this is, I can multiply that by this, and it's the same thing, isn't it? What is I to the negative 23rd times I to the 24th?
I.
Isn't that the same answer we got after all this shit? I got it really quick. Right? There's almost always a shortcut because you understand something. The more you know, the less you have to do is one of my favorite math things.
I believe, for me, actually, the first time it's supposed to be minus or negative I. This is the answer. But, yeah.
Yeah, the negative is in the power. That means flip. It's a few too many of us are doing stuff like this. That's never true. Right?
No,
that's never true. So be careful. Negative numbers can't become... No, that's not true, right? Please, dear God. 4 to the negative 1 is 1/4, sure, because that's what powers do. Negative powers flip. Yeah. Yes?
And the reason that you rationalized it is because you can't have a negative on...
It's just convention to not end up with a radical on the bottom. And like somebody pointed out, I is a radical. Right? So you just do that one extra step. Yeah.
Okay.
But if you got here, I'd be okay with it because we didn't work with I enough to realize you should keep going. But yeah. Sorry. Yes?
Are we going to learn section 13 today?
Yeah, I was going to talk a little bit about it, but I wanted to make sure I got all this done first.
And that'll be on the final also, 13?
No.
No?
Maybe on the bonus. See if I don't know. We'll see.
You can go for logs again.
Oh yeah, we can do logs.
3D.
3D, yes. Yes?
Yeah.
Alright, so 3D, what's your first step?
-3.
Good. Alright. And you did that, so now I can do what?
Squares.
Square. I don't want to square the way it looks first because I got to foil that other thing. The biggest mistake I saw is here. A lot of people are just telling me that. Come on, come on, come on. What is that?
+6.
Yeah. And on this side you get
1 minus 3x.
good.
Factor.
So now what? Now you look at it like it's a whole new problem. What would you do with this kind of problem?
Break up the x.
You want to get all on one side, right?
Yeah, I got to get it equal to
0.